Okay, in the previous video we discussed about class A amplifier. Now let me discuss about class B amplifier. I have already said that this classification depends on how the output waveform appears. Though it is amplified, the output waveform may be full cycle, maybe half cycle, maybe less than half cycle, and goes on. Right. Class B amplifier. The circuit diagram of a class B amplifier is shown here. A transistor is connected to the base. Again here, the base of the transistor is connected to an AC input signal, and the emitter is acting as a common emitter configuration. It is grounded with the help of a emitter resistance, and the collector is given to the supply VCC. The collector current is allowed to flows 180 degree only. See the input and the output waveform. It is well explained with the help of a load line graph. It is well explained with the help of a load line graph. See the load line graph. The y-axis is the collector current. The x-axis is the collector emitter voltage. A AC load line is 45 degree or 60 degree tilted. It is drawn here. It is represented by an AC load line. And see here the Q point. The Q point is an important point which acts as an axis. The Q point is in the x-axis. And it acts as an center axis for both the waveform, right? The input signal is 45 degree tilt, which is in the right of the Q point, which you may see that it is an AC sinusoidal waveform. The input is AC sinusoidal. Whereas how the output behaves depends on the AC load line graph. The output, see the output, only a positive half cycle appears as the output voltage, since the Q point is in the x-axis. If the Q point is greater than the x-axis, then the negative waveform also appears. Therefore, the advantages may be the impedance matching is good. It is also higher efficiency while comparing with the class A amplifier. Whereas, since the waveform is distorted, you mean the negative of M doesn't appears, a crossover distortion may be present. The crossover distortion may be present in the class B type. In order to overcome this crossover distortion, another arrangement comes into picture. You mean both the positive and the negative. Both the positive and the negative waveform appears as the output. You mean one transistor will act as a push arrangement and another transistor will act as a pull arrangement, such that both the positive and the negative waveform will appear as the output. And it is named as class B push-pull arrangement. Again, the same explanation of a transistor acting as an amplifier remains same. Whereas see here, there are two center tapped transformer. One is connected in the input side. A center tapped transformer. A two center tapped transformer is here. One transformer is in the input side. See here in the input side, the primary is connected to the input AC signal where a sinusoidal waveform appears. The output of the center tapped, again divided into two windings. One is the upper half limb and another one is the lower half limb. In the upper half limb, positive waveform appears first, whereas in the lower of limb, negative waveform appears first. And these two, positive and negative waveform, is given to a transistor Q1 and Q2. Again, it is a common emitter configuration with biasing resistance all comes into picture, whereas for a sake of a neat circuit diagram, it is not represented here. And this Q1 and Q2 transistors amplify the signal and also invert. See the output of a Q1 in the collector terminal. The output waveform is an inverter mode. The output waveform is in the inverter mode. Similarly, see the output of Q2. The output waveform is in the again inverter mode. You mean the positive waveform appears first and the negative appears second for Q2. And the negative waveform appears first and the positive appears next in the Q1. Again, it is given to another transformer where again it is a center tapped. Now what will happen? Right. This division of waveforms will again joined in the primary side. This division or bifurcation of the waveforms, two waveforms, it is joined in the primary side as an amplified mode, whereas the positive appears first and the negative appears second. Though amplification is also done and double inversion is done, therefore positive remains first and the negative remains second, whereas the transistor Q1 and Q2 will act as a push transistor and another act as a pull transistor. Therefore, no inversion, only amplification is done. Therefore, it has more advantages than ordinary class B amplifier. Push-pull amplifier is having a very good applications. Here, for the neatness of the circuit diagram, the biasing resistor, the emitter resistor, the collector resistors are not shown here in the circuit. Thank you for patient listening. Hope you understand this. Thank you.